Welcome back to another episode of essentially building AsyncIO agents essentially on top of Tokio. And this episode, we are going to enhance our message generator. So let's jump to the implementation of message generator. And essentially what we want to do here is control this agent. Because imagine essentially this agent running on the runtime. And at a certain point, for example, we want to quit this. So how I imagine, for example, a message generator, it could be like a WebSocket connection, right, to some kind of data source. And this WebSocket connection is just like sending messages all the time, right? But for some reason it could stop, right? So we also, for example, want to know metrics. And so how much have you processed essentially in the last minute or second or whatever. But we also want to know, for example, if this message generator is healthy, right? And so just from its perspective, is this a healthy one or not? And of course, we want to quit it, right? So one way to do this, right, would be essentially using something like shared memory, mutexes with locks, right, with atomic reference counters and all that kind of stuff. But essentially, in the domain of agents, this can lead to essentially like locked situations, where two kinds of processes want to lock each other, right? And this doesn't really work that well. So often, essentially, and what we are going to use is like a control channel. So what this control channel essentially will do, it will just essentially send messages as well. So that now suddenly it means like we have like one incoming channel, and I want this message to be like a quit message, and I want it to perform essentially a health check, right? So a health message, right? So, and I want essentially the health check to send me back a response, right? From essentially, am I healthy or am I not healthy, right? Or not, right? So how are we going to do this, right? So first of all, let's implement this quit message, right? For this, we actually need another channel, right? So let's put another channel here, which essentially is a control channel. And this control channel is a receiver, right? Because essentially it receives comments essentially from another process. So now we need to now we need to design, okay, so how is this going to work? What kind of message is going to receive, right? So let's make a control message, right? And to design it, let's make an enum. What we also know is what the messages have to be, right? So for example, we want post to be quit, and we want them to send a health message. But let's focus first essentially on only quitting, right? So now we have implemented this. Let's see if it works. We of course need in the main function, now we need to change the function signature. So now we need another channel, right? So let's call this control channel. And this is going to use control messages. Now we don't have that control message yet, so let's import it. And of course we have to make it public, as we saw in our previous video, because now we need this essentially in the here. So now we can pass this control channel as well, but it's a receiving part. This is also again like a beautiful thing about the type system. So for example, just thinking about it, it saves so much time than tracking back these bugs, right? And so just so for example, I put here in a sender, right? And it says, okay, it should be a receiver. It's like beautiful. I really start to appreciate this type system of Rust, and especially also the way essentially the compiler shows you, how clear it shows you essentially the messages, right? You could essentially say that the compiler output is then essentially the user interface into the language, right? So just like imagine this message being very succinct, right? So now it's just so beautiful. Like, okay, you immediately know, okay, receiver, sender, blah, and you know what's going on, right? It saves so much time. It really creates a flow when programming. But okay, well, let's say now we have essentially a controller channel, right? But now we have it. What are we going to do with it, right? So he says remove the mutable, and this is a warning, okay, but we're going to leave it in for now. So what are we going to do, right? So now we have it. We're going to wait like 2 seconds. So this should print essentially 20 messages, right? Because we're sending every 100 milliseconds a message. Now, so let's start implementing essentially the quitting of this process. So we have like a control channel, and we want to send essentially this message to the channel, to the agent running, right? So it says, okay, cannot borrow mutable. Agree with this. So let's just change it, and we get a warning. And this warning says, I'm not using a result. So essentially, what this means essentially is that this normally returns a result, right? And you should use it. Now, what I always like to do, for example, in some cases, is use the question mark operator, which I really like. And now we get an actual error, right? Because essentially we need this main function now to actually return fallable. And we have to include this, use failure fallable. And if you look what fallable is, then we see it's like a standard implementation of a result type with essentially an error, right? So it's like result which gives back this error, and this error will resolve to an error implementation, right? So let's go back and see what he's saying now. So okay, of course we need to return something valid in correspondence, and now we have essentially something working. But now it needs control message needs to implement debug, because it needs to print essentially debug information for the error to work. So now we have like a valid implementation, right? So what does this question mark operator do? This is very interesting to look at. And what it does is the following essentially, right? So so adding this question mark, what it essentially does, let's just assume that this is the value. What it essentially does is the following, right? It says essentially the following. It implements a match with the v on the value, and then essentially it has two branches. It has the OK branch with some kind of value, yeah, and then essentially it will just return the value, right? But the other branch is the error branch in our case, because we use it fallable, and this will result in a return of the function with an error. So that means essentially that it's either we match, so v, we can now transpose this one. So either we have this without question mark, of course, and now essentially if it's okay, we return the value, and if it's an error, we essentially return directly the error. So we exit the function essentially, right? So we short circuit essentially this whole await function and just directly essentially exit. So this is essentially what the question mark operator does. So, but it's of course easier just to write this, and now we just send a control message to our message generator. But now comes, of course, the following part, right? Now we need to do something with this control message. And to do something with this control message, we need to, of course, adapt our message generator. So essentially now, it's just essentially sending messages, hello, 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 which is, of course, all fine, right? But it's not really what we want, right? We want him also to act on the control message. So how are we going to do this? We are going to do this as followed. Now, essentially, we're going to bring in a new concept, and that's essentially the select macro. You have this for threads, but you also have like a Tokio specific select macro, and we have to bring it into scope. So we are going to do like Tokio, and we want to use the select macro. And now suddenly what we have is this thing. Now we have essentially Tokio select available. And what select essentially does is you can put like multiple async keywords here, right? So async that return a future essentially, like futures. You can do like future, and then you can say, okay, when this future does something, then actually execute this code block, right? And then you can essentially make multiple. And what select essentially does is that it takes the first, so let's say if this resolves, so essentially runtime is going to pull all of these, right? And then if this one pulls, right, is ready, then essentially it will get a value and it will execute this block. If this is going to be ready, then it's going to do this one, or this is going to do ready. So essentially it's some kind of, essentially, so it allows you to listen to multiple, for example, multiple channels, right? So let's do this. We have this piece of code, which now belongs to essentially this future. And notice that I don't need to do the await here now, right? And so what we now say essentially is, okay, the message. So if you receive a message from this channel, right, then execute this match. Right, I'm going to format this a bit. And essentially nothing has to change here, right? So still on an error, we want to break the main loop, right? So everything's the same. But now we have this essentially in place. We have something else we can add, and that is now a control channel, and that makes it very interesting, right? So now so this we need to end with a comma. Let's check. So this is the match. So I need to be here, and now we can do our next things, and this is then the comment. Say the control message is control channel receive, and what we have then is essentially we match on the comment, and then we can say, okay, if we, so this is very important, of course, like the receive takes back essentially an optional, because it can be something or it can be nothing, right? And if you check the documentation, then you will see that essentially it can either return a sum, because it's returning an option with a message, essentially, like a control message, or it returns a none. I need to change this. Control, some comment essentially. So this could be like a comment, or it is none. or it is none. And essentially when it's none, essentially that means essentially all sender halves, so do it like this, all senders have dropped. So that means essentially there's nothing more to receive, and essentially then actually we could, for example, also break this loop if we would find this a requirement. And if there's a comment, then essentially we can start essentially interpreting those comments, right? But we know what the comment is, right? So this comment, because we defined console quit, now we can just say, okay, if we get this, then we just break the loop, right? And if this happens, we can also break the loop essentially, right? Not like this, yeah. So now what we've implemented, like a recap, is like select can be used essentially to listen to multiple futures and essentially start executing once one of these futures are ready. And what we do now is, let's say if we loop, right? And then essentially we just say, okay, we are going to send these messages, right? And essentially if this one is ready, then essentially we could react on this one, right? Okay. So let's try to compile. We have some errors, I see. Okay, so sleep. It says expected 1 match. It needs of course a value. Otherwise difficult to match. And essentially we have a working compiling version. So if you execute, then essentially what we see now is, okay, it runs 20 and then it stops. But of course we want to see what it exactly does. So let's go back to main. So now we could say print line quit message send, right? Oops. Okay, anything here. And what we also want to see here is if the loop is done. Now, for example, we would like to see, let's say, message generator stopped. Okay, that's perfect. So if you execute now, then we see sending message, quit message sent. It's quit, so it's send the message. Right, it was still processing one message, and then afterwards it's essentially stopped. So I think this is the intended behavior. So here essentially quit message sent and directly stopped, right? So it's perfect. That's exactly what we want. And for example, let's do another print line here, and it's an exiting program. Exiting program. Alrighty. So now we controlled essentially the asynchronous agent with a control message, right? So now what we want to do, for example, now we need to add on to this, right? So what we want here is, for example, also show me your health, right? And now comes the interesting part, right? So we want to send this agent a message, but we also, of course, need a return. So how are we going to do this? So what we could do, for example, is add another channel back. Yeah? So we could, for example, say, okay, we have a control channel, and then we add essentially a control receiver channel. That would mean like we have to another parameter here, right? And then essentially we would have to create one in main, because here of course we need to control the receiver channel, and then we send something, right? And then we await it, and then immediately there we wait on the receiving channel with a certain kind of timeout you know, to get it back. This looks is a bit complicated, right? So the pattern that is being used in Rust and also in other implementations is called a one-shot pattern, like a one-shot. And the one-shot is like a channel that can be used just only once, right? So in that case, we could, for example, and that's the beauty again of Rust, we can give some data, you know, next to this message, and then we say, okay, let's use this one-shot, and I want to send something back, right? So I want to send sender, and then essentially I want to send back, for example, a health response, right? Very simple. Now, of course, we need to include it. Use Tokio sync one shot. Yes, and then now, of course, we need to define a health response, and let's make an enum of this as well. So let's make it enum health response, and let's say I'm healthy or I'm unhealthy. Very simple one. So health response. Okay, it needs to debug because otherwise it doesn't work. Makes sense. Okay, so now we have essentially a data structure ready, right? So now, of course, we want to call this function, and let's do this before. So we first, let's say, let it print messages, then we again let it print messages, and now we're essentially going to do health request. Then we're going to wait, but now we're going to send. Now we are going to send a health response, a health request, health message, send. But of course we need a one shot here, right? We need now a way essentially to return this value. So again, same pattern as here. So we have a one shot channel, and it doesn't need a buffer, right? Because it's like 1. And we have it here. And now, of course, we need to include it. Let's take it from here. And sync up. Okay, yes. And now we have a one-shot channel. Now we only need to essentially receive the value, right? So to receive the value, we want, of course, the agent to send it to us, right? So we need to pass here the CTX, but in this case, we need to, of course, make, we're going to call this the response channel, right? So now essentially we have here, with a little more warning, let's remove it. So now we have essentially a one-shot channel. We send a message, and then we move essentially the value in the things. Say in this message, right? So from the borrow checker, it's like move now, but we're never going to use it, right? Because to get the result, essentially, we are going to await it. Yeah. So the nice thing about the one shot is that you don't have to call any other message because there's only one message, so you can just await directly on the channel. So we could say like the response, that's response is just essentially the return channel, rrx.await. And of course, we're gonna leave with an error if it doesn't pan out correctly. Right, we covered the question mark operator, and now essentially we just print essentially the HealthResponse. And we're going to do this like this. And of course, response. And of course, we need receive health. Response is this. So now we have essentially, okay, so just to recuperate, so we make a one-shot channel. We're going to send this to the agent. Yeah, we're going to move essentially the receiving end essentially inside the message, and we're going to send it to the agent. So now it will receive here, and this is again the beauty of Rust, right? So now it says, hey, you know, we have some patterns that are not essentially covered, right? And it also gives you the patterns that aren't covered. And this is again an example of how important essentially these messages are, right? Because let's say Ross could just as well have said like, okay, just like not all patterns are covered, right? And then just figure it out yourself. But he also takes the trouble of essentially listing which one haven't been covered, and this makes it like so much easier, right? It really helps you essentially to cover all the cases. So we need to implement like the health thing. So sum, and then we have health, control health, and now we're going to pick out essentially the thing we want to have, and that's essentially the response, say the response transfer channel, because we need to send something back, and then essentially we are just going to send back something called RTX send. Let me think about this one, and we're going to do like the health response, and we're going to say we're healthy, and we're just going to unwrap this thing. Exactly. So when this cannot work, essentially it will panic. Yeah, so that's because then essentially we cannot send something back, and then the whole thread will die, and then of course it's automatically unhealthy. But that's something else we can cover the next time we talked about this. But so essentially now we see the pattern essentially. Yeah. So and to summarize, so how do we essentially talk to our agent? And this is a very nice pattern, so which you can use the one-shot channel, right? So we need these. So we need a return value to receive a return value. So we send it essentially inside the message of the enum, and then essentially we take the response, we await the response, and then we have like things. Let's test this. Okay, interesting. Can't be private type. So that means that this also, so if you make this public, then also this has to be public. And there we go. Writing. So what we see happening essentially, if we scroll the bug, okay, so writing, health message sent. It's writing another message in between, right? And then received, response, healthy, and then it starts writing. So now we can see the power of essentially async programming in Rust, and we have discovered essentially the basic patterns. So at this point, just to summarize, we know we can spawn essentially these async functions, and they run in the background. We know now we can communicate with them essentially using channels, right? So we can link them together using channels. And we have now a model where we can essentially request some information and essentially receive a response by using essentially the one-shot channels. And this all passes the infamous borrow checker of Rust. I hope you enjoyed essentially this implementation, like this very specific implementation of two agents, which essentially showed the general patterns of agent implementation. And next episode, we're going to continue essentially building our agents. Thank you for watching.